Today we will understand about what is thermal energy and how does thermal energy transfer. Heat is a form of energy and is sometimes described as thermal energy. We know from our everyday experience that objects lose and gain heat energy, such as if a hot drink is left to stand, it will eventually cool down until it is the same temperature as the air around it. Similarly, if a cold drink is left to stand, it will warm up. When two objects at different temperatures are brought together, heat is transferred from the hotter to the cooler until they both are at the same temperature. All matter is composed of particles, atoms, molecules, or ions. When an object is heated, the thermal energy causes the particles to move more rapidly. The kinetic energy of the particles increases. Conversely, when an object is cooled, its particles lose kinetic energy. There are three different ways in which thermal energy may transfer: conduction, convection, and radiation. In solids, the particles are held in fixed positions. They do not move position but they do vibrate. When a solid is heated, the particles vibrate more energetically. The particles jostle neighboring particles, which in turn jostle their neighbors, and in this way, kinetic energy is passed through the solid. This process is called conduction. All solids conduct heat to some extent, but some solids are much better conductors than others. All metals are good conductors of heat, while most nonmetals are poor conductors. Poor conductors of heat are called thermal insulators and include glass, plastics, wood, water, and air. We can explain this by considering the structure of metals and nonmetals. A metal consists of a matrix of positively charged ions through which mobile electrons or free electrons are able to move. These electrons are described as free or delocalized because they do not held by any particular metal ion. When a metal is heated, the matrix of position ions vibrates more energetically, just like the particles of any solid. But in addition to this, heating increases the kinetic energy of the delocalized electrons. The delocalized electrons move more rapidly and are able to transfer energy through the metal very quickly. Nonmetals do not possess delocalized ions, so energy transfer through them is much slower. Thermal insulators and thermal conductors have a number of important uses and are sometimes used together, such as the conductor and insulator may be used together like a pan. The body of a saucepan is made of a metal like aluminium. Metals are good conductors of heat, so heat is conducted through the saucepan to the food very quickly. The handle of the pan is made of non-conductor like plastic or sometimes wood. The non-metal is an insulator, so the handle does not heat up as readily as the metal part of saucepan. This allows the cook to hold the saucepan without burning their hand. Although plastic is an insulator, heat can conduct through the sides of a thin plastic cup more quickly than the person drinks. A cardboard collar may be used to make it easier for the person to hold the cup. Moving towards convection. The particles in liquids and gases are too far apart for conduction to take place effectively. Heat is mainly transferred through liquids and gases by another process called convection. When the particles in a liquid or a gas are heated, they move about more quickly. The particles spread out so they are further apart from each other since density is equals to mass upon volume. Meanwhile, the density is directly proportional to mass and inversely proportional to volume. It follows that when the volume increases, density must decrease. This decrease in density is the essence of convection. It is possible to observe convection taking place in water by introducing a colored chemical or doing dye to it. The particles responsible for the color are carried by water as it moves. When the water around a colored crystal at the bottom of the beaker is heated, it becomes less dense and rises, carrying some of the color particles with it. Cooler water from the top of the beaker falls down to replace it. Overall water rises as it gets warm and falls down as it gets cool. This movement is called convection current. Convection takes place in gases in exactly the same way as in liquids. We can see convection in a gas by observing a fire. Smoke particles from the fire rise because they are carried by the hot air. Birds of prey know all about convection currents. They spread their wings and rise up on the air, which has been warmed by the land. The birds can rise to great heights without having too much use of energy. It is important to appreciate that during convection, it is not the only just the heat energy that is rising, but the heated liquid or gas. The heat energy increases the kinetic energy of the particles in a liquid or gas. The Earth and the other planets are separated from the Sun by the vacuum of space. A vacuum contains nothing, no solid, no liquids, or no gas. How does heat therefore travel from the Sun to the Earth and other planets? Clearly, there is a third way in which the thermal energy can be transferred. This is called radiation. Heat radiation consists of infrared waves that can travel through a vacuum much in the same way as visible light. Both infrared and visible light are part of the electromagnetic spectrum. Radiation is the emission of energy as waves or particles or rays. Radiation does not require a medium to transfer energy. Radiant energy is either reflected or absorbed by matter. The energy that is absorbed increases the kinetic energy of the object. This increases the temperature of the object. For example, frying pan on a stove top. Energy is radiated from the heat source and absorbed by the lower surface of the pan. For example, the sun. Sun radiates energy in form of solar radiation. When this energy reaches earth, it is absorbed by matter such as air, water, and land. Absorbed radiant energy increases the kinetic energy of the matter, rising its temperature. The sun is an emitter, it gives out heat, and the earth is an absorber, it takes in the heat. Also, knowing about the surface area. The larger the surface area, the higher the rate of transfer. Thermal energy transfer in the atmosphere. Things to know. What is atmospheric pressure? The pressure exerted by the mass of air above any point on Earth's surface. Warm air is less dense than cool air. Warmer regions generally have less atmospheric pressures than colder regions. Wind, the movement of air from areas of higher pressure to areas of low pressure. The rising and sinking masses of air in convection currents causes changes in atmospheric pressure, causing wind.